Welcome to the Where Shall We Meet podcast. Our guest today is Dr. Amanda Parks. Amanda calls herself a fashion scientist. She has a PhD from the MIT Media Lab, where her research bridged computer science and material science, and dual Stanford degrees in mechanical engineering and art history. She has spent 15 years trying to answer a deceptively simple question. What if we rebuild the material world around nature's logic instead of against it?
That question has taken her from algae biofuels to 3D printed couture, from developing science exhibits at the Exploratorium in San Francisco and the science museums here in London, to running R&D at Pangaia, the company she describes as a material science company masquerading as a fashion brand. There she turned wildflowers into jacket insulation, Himalayan nettle into denim, and carbon dioxide pulled from the air into sunglasses.
She is now CTO at Mothership Materials, where she's gone even deeper, extracting the building blocks of biology from food waste to feed the next generation of biomanufacturers. We talk about
fashion as a material science,
designing clothing as part of a biological cycle,
high-tech naturalism,
how algae can transform into clothing dye,
biofabrication,
humans are good at building, but not at breaking down.
using carbon air pollution to make ink.
How banana skin can become your next dress.
Let's get dressed. Hi, this is Omid Ashtari.
And Natasha McElhone.
And with us today is
Amanda Parks.
Hey, Amanda. Thanks for taking the time.
Thanks so much for inviting me.
So, we have a lot of ground to cover today, but we thought that a good starting point would be talking about the fact that you call yourself a fashion scientist. You've also said that fashion people and scientists don't mix at all, just like water and oil. So tell us how you managed to overcome these incompatibilities as a person.
Yeah, so I do call myself a fashion scientist. I'm not sure if I invented the term, but it's been working, at least gets people's attention. I think for me, it kind of went back to the fact that I was one of those kids that loved and was good at math and science, but also was totally glamorous little LA kid and would be obsessing about my outfits and colors and all that. And luckily I had a family and kind of a schooling situation, which no one told me that this was incompatible. So I was kind of able to do it. And it wasn't really until I got to kind of undergrad at Stanford that I sort of figured out, like, oh, the engineering department's way across campus from the art department. And this was in the 90s, and things have changed a bit now. But I think this idea of merging the two, there's a lot of crossover in terms of creativity, kind of ways of thinking about the world, notions of curiosity and exploration that are kind of cross-functional between fashion and art and science. And it's been sort of more reason that they're being recognized. But the bigger problem with the fashion industry is just that it is very separate as a discipline. I like to talk about the fact that the Jacquard loom was the precursor of the first computer, right? Fashion is inherently a technical domain. The way that textiles are made, if you get into it, it's incredible. Fiber science, right? This whole back end. But I think because fashion is seen as so glamorous, it kind of in the media or with the public consciousness is seemingly superficial, right? And it's deceptively superficial. And so in that way, there was an article on me in like MIT alumni publication, and it was about my work in fashion and how it was applying science into fashion. And I got a lot of hate for it on Twitter, like, she wasted a spot at MIT, she's working in something so silly. It was quite interesting to see this kind of backlash on it. So with my career, I've just been very interested in this crossover and everything from, I've worked on re-architecting the inside of a high heel to be safer and more comfortable for women with literally astronauts and SpaceX engineers, right? There's a really complicated problem involving body dynamics, materiality. It's actually really complicated to design for the body. And I think some of the best engineers I've ever met are pattern cutters, people who can drape and like they can see in 2 and 3 dimensions with a textile, which is a fluid. We don't have robots that can sew with the dexterity of human fingers yet. So there's a lot of pieces to it that are really, really complex. And because it's been under-examined by the kind of current state of engineering and science, there's so much ripe opportunity there. And that was, I think, one of the things that kept opening up to me for my career. The former head of talent at SpaceX came to me and saying, what's inside my shoes? Why can we not make something better? And just this entire notion of what's out there. And just because of my overlap of interest and potentially being a woman and just kind of being in the space and being very comfortable in fashion, it has sort of shown me a lot of different things. Also in wearable tech.
Yeah,
right?
you're pointing out the one side of it, which is saying the engineers are not so focused on fashion.
Yeah.
But I would also argue that the fashion industry itself is not really focused on the R&D as such.
Yeah.
Like we see all the R&D going into how do I make things cheaper and more scalable and then non-scalable way for the planet rather than into R&D.
That's a huge point to make. And fashion industry has been notoriously, there've been restraint about allowing innovation in. And I think there's some good reason about respecting craftsmanship and these kinds of artistic practices and wanting to preserve them. And I'm a huge fan of that. It's more about how we can sort of let the tech in. The other thing that was incredibly interesting to me, because I came from the engineering and science side and kind of took the back door into fashion, right? Through wearable tech and projects in that realm. And I was shocked to find out that the really big fashion conglomerates did not have their own internal R&D. So the same way that Intel makes its own chips, Google builds its own software, right? They're not making their own textiles or doing their own research. And that was also what I saw as a huge opportunity to kind of step in. And how can fashion start to own the means of its own production and do that? I will say that I have been very impressed in the last kind of decade about how they are opening up to it. It's the models and mechanisms that are still a little bit behind and broken, and those things need to change. But the attitude and aptitude is there and changing. That's encouraging to me.
I think that a lot of the things that you referred to and that we're going to embark upon talking about are essentially saying there is a reality of evolution that has worked on building the most efficient manufacturing platform on planet Earth or in the known universe, maybe even for 3.8 billion years. And now what we want to do is essentially use that rather than using processes that are not necessarily native to the planet, right? Is that a fair thing to say that that's what your career has been focused on to an extent?
Yeah, I think what you're kind of intuitively saying is this nature of biofabrication, right? That we return to the processes of nature. And I think it's not just about the manufacturing possibility, but I think it's sort of about how do we have done amazing developments in all kinds of manufacturing, and it's about respecting how that works in balance with nature. Now, some of those things we can do absolutely using the mechanisms of nature, like using microbes to grow things. And other things do make sense. If we're going to cast metals, we have amazing injection molding technologies, right? So we can, start to run those off of alternative forms of energy, right? It's mostly about keeping everything in balance. So we respect the kind of technological development that has fundamentally changed how we lived and made it more comfortable and allowed us to kind of move into the spheres of technology and innovation that we have. But looking back on that, like when I was in engineering school, we were absolutely not taught to consider any of those things about energy and sustainability. I mean, maybe a tiny bit. I'm being a little bit unfair, but in general, technology is about progress. And one of the questions that used to come up at MIT was like, just because we can, should we, right? And that's been, I think, a little bit of a marked change in the last 20 years. We're starting to question the ethics and also just literally the sustainability, not just in terms of environmental sustainability, but can we keep doing this, right? Is this a good idea, even if we can do it?
Also, I think the surprising union of engineering or technology and fashion that you're managing to bridge. I mean, fashion seems to be predicated on it's disposable, it's the newest, it's incredibly fast, you want to be ahead of the season. Even fashion shows themselves are all about that, predicting what's going to be the latest craze next year. And it's the spread of that people get excited by. There's a massive cultural shift that will need to happen for people to accept that. I remember thinking when I was little that, in a way, when I looked at sort of iconic figures, whether it was Jackie O or there was sort of uniforms that people had, right? Or even someone like Steve Jobs, even not a sort of screen goddess, there would just be these iconic outfits that they would wear, whether it was someone only dressed in black and white, or Annie Leibovitz had a certain outfit, I think, and these designers as well, people in fashion. And I kind of thought, well, that kind of makes sense. People tend to wear the same things, the things that suit them. So I was like, I wonder if we could create an outfit that just lasts for life. that you know, and it's a bit like, do you know that guy Joachim Mitchell, the architect who makes edible housing, right? It's sort of like, I was thinking when we get to the end of your story, it's sort of almost like, oh, you could just eat your T-shirt just before you die.
I have stories about that. So first of all, I want to challenge you on that notion, because it terrifies me to live in that world. So just personally, because one of the reasons I love fashion is it's a means of personal expression, which could be that it's about having uniform and that you feel comfortable in that. But the other side of it is that it's a way that we actually speak to the world without speaking. And I was a really shy kid. There's so many visual signaling and communication that happens with it. And I love the idea, especially for young people, to be able to experiment with that and to have it as a nonverbal form of communication in terms of development. And one of the reasons that I've become so interested in the nature of creating fashion that has more of a biological basis is to challenge this notion of fast fashion, right? We have created something that is disposable, but is made of a material that lasts forever. So this is a design problem, right? It's not the medium is not meeting the task. But what if we had fast fashion that I used to say works like Snapchat or works like Instagram stories, where it's literally designed to be around for a season, a month, a week, whatever it is, and then it naturally disintegrates. There's this material, chitosan, comes from the waste of shrimp shells. It's a beautiful translucent material. There's so many things in the ocean that are underexplored. But it's stable in like regular fresh water, but it disintegrates in salt water. So what if the mechanism is that you wear the thing for as long as you want, and then the disposal is to throw it in the ocean and it disintegrates, and that's its natural form, right? So there are these different biological paradigms. Nature has so many things that are disposable. Leaves, right? And if we don't do anything to make them non-disposable, we can operate in that paradigm and have things that are disposable. I also think in this realm, and this is where digital technology and new platform where you can post your local closet, like down to like the street, and I live in Brooklyn in a cool neighborhood. And it's like, oh, I would love to know that woman with that closet. There's something that's a lot about identity. And I think we could actually build communities around it. And maybe this is a little bit fashionista, but, we all have, it's like things that we identify with in our hobbies. And I love the way that a means of sharing is something that can bring people together through these objects.
Totally agree. And Tessa Clark of Olio, who we interviewed once, says this is her whole platform is around sharing these things and no waste. And if we go back 100 years, that's what our relatives used to do. They would share clothes. So that's all good. But I've totally taken us off piste, and I'm going to allow him to bring it back.
No. I think this all fits together. So the thing that I wanted to actually ask was like, is this a culture problem or is this a science problem? And I think you very well established that it's actually a science problem rather than a culture problem, because ultimately this is a beautiful culture. It's a culture that inherently kind of connects people. It allows us to express ourselves. This is all what humanity is about. But it's a science problem that needs to adapt to the materials to the actual use of, to the use case, right?
It's a science problem, but we're starting to have more of the right materials. It's a business culture problem.
True.
In the sense that the invention of fast fashion was all about infinite growth. Like, the models were like literally hockey stick, Silicon Valley levels. And that is just unsustainable.
But with the right materials, you'd say it still would work, right? So it's a business issue.
Although I wouldn't say anything should have infinite growth. Like that doesn't even make sense, right? It's all about the planetary boundaries, as we said. But this very nature of you can't even have just like a consistent sell through for this stuff. It's what we call the race to the bottom.
Yeah, exactly.
Right. The more and more you're producing, that's the only way your company can exist, then you're eventually going to get to markets where there is no longer any new markets.
So tell us about your philosophy, high-tech naturalism. I think this is a good point to bring that in.
Yeah, absolutely. So when I was, working at Pangaia as a chief innovation officer, I had developed this philosophy around like, how are we going to look at the world and what was going to be our brand idea? Think about sustainability, right? what does it mean to have a brand that is actually making and selling things? And how can we be, respect both of those things, the science, purpose, and design angle all at the same time? And so I termed the phrase high-tech naturalism. And what that means is that we look at the world from a place of abundance, right? So it could be things like, oh, there's fall, the leaves are falling, there's tons of this on the ground that we could use for something. So it could be those sort of positive things. It could also be, look at how much carbon we've created as pollution. Hey, wait, let's twist it around and think of that as a resource which we can turn into things. And we are doing that now, right? How do we, it's about thinking about the world in balance and then using our highest levels of science and technology to augment those things that we have. So the very nature of doing actual carbon capture and turning it into proteins or turning it into plastics, the basis of bioplastics. And so this was about literally technology working in support of sustainability. And that was kind of how we were balancing the nature of doing very high-tech things like biofabrication and like carbon capture, and then things that were considered very like low-tech or, in the what they would consider more of the hippie realm of making things from agricultural waste. And I think those two things need to blend together, and that's where I was seeing it happen. And a good example of one of the materials that we worked on was something called flower down. And this was made as an alternative to goose down, but also had no synthetics. And, one of the biggest problems around language right now with fashion is when people talk about vegan leather, they're actually talking about is plastic. And we need to be very clear that all these brands have been like, oh, no, we're making it, we're going along with the vegan movement. No, you're just killing other kinds of things in different parts of the biosphere, right? So the point being that we were looking at something that was an alternative to animal down if you didn't want to have animals, but it also had no synthetics. So this was made from waste wildflowers mixed with biopolymer and cellulosic aerogel. This is a very high-tech material, aerogel. It's incredibly light, right? The whole development of it. But it was made, all those components were compostable, and then when combined, they gave the kind of softness and internal structure and durability of a down. This matching of taking something that is very techy in the lab with a material that was literally collected as a weed and putting those two things together.
And the synthesis, just out of interest, what is the sort of energy consumption of one of these processes?
It's actually relatively low. And with energy, we do obviously want to keep things at lower levels of energy, but really it's thinking about where can we get that energy from? And if it can be from a renewable form of energy, that is less of a concern than the actual material resourcing that we're using. So because we have so many methods of renewable energy, solar, wind power, and also very localized forms of energy, right? And how we think about that balance. Energy we should be very aware of it, but we don't have to think of it as much of a limited resource as we do as something like rare earth metals or petroleum, right? Those are fixed numbers. Energy is literally about matter changing states.
Nice.
And there's infinite solar energy that we can tap into, really.
Yeah, exactly.
Yeah. I think maybe worthwhile just briefly talking about cotton and polyester. They scale, they seemingly work, right? What's wrong with those things? And what are some alternatives here?
Yeah.
Apart from the flower down there.
Right. Yeah. So the issue with polyester, I think we all know the synthetic nature, but I think it is important to touch on why is it so bad to pull up oil from the ground? And the thing is that to pull up some of it was actually okay. It's all about actually how much carbon we're releasing into the atmosphere. And it's about this rebalancing again, right? So we've just pulled up way too much of it, and we keep doing that as opposed to doing things that are actually kind of rebalancing. The other thing is that we have actually created from that materials that are non-biodegradable, that are non-destructible, and also are breaking down into components that are literally infecting our bodies. I think we all know about the microplastics problem that's compounding what we're already doing with that excess carbon. So the materials themselves leave traces of being inherently dangerous to all human life, animal life, plants, etc. So what is happening with contemporary cotton production is that we're growing too much of it in a conventional way that involves too many pesticides. And so the land is being stripped and then it's unable to be utilized long term. So what we want is to use cotton for what cotton is good for and to grow regeneratively. this idea that we should just sort of have less cotton in the world. And the point is that we can balance that with the thousands of other fibers that are out there that have been not yet developed or discovered, right? So you go to Brazil, there's like 100 different kinds of banana fibers that they're researching in labs. They're incredibly strong. They're beautiful, whatever. They just, there's different processes to get them into the kinds of textiles that we're accustomed to. And one of the things that we did at Pangaia, I was like, this was my favorite textile that we developed. It was called fruit fiber. We had a whole series called plant and fruit fiber. And it was to show that we could make something that was like a beautiful drapey jersey like cotton would have, right, in a garment, but be made entirely from agricultural waste. So fruit fiber had the waste from banana plants, the waste from pineapple, and a seaweed blended together. And we got the kind of finish that we wanted. These are all made in the form of lyocell, so like a man-made celluloses, where you take the cellulose from this fiber and basically powderize it and then extrude it. The reason it's such an amazing plant is that you can just literally pull the fiber from the plant. I wouldn't say it's simple, but it's been around for thousands of years. And so this is a little bit more involved in the engineering, and we're getting better and better at utilizing these alternative forms of cellulose to make the kinds of textiles that are not just can be replicant of the functionality of cotton, but we can start to also work on the functionality of nylon and polyesters just through the finishes and through the way that we're making. So if you think about it, what we're going after is the performance of what we think of as a synthetic textile, but with the basis of a bio input. And that's really the future of like how we can really start to shift away from our dependence on synthetics.
And what's the uptake from clothing companies?
So this goes back to cost. So first of all, really high-end cotton, we're going to leave that alone and use it, and we love it. Like, let's just be there. If we can grow regenerative cotton, we should, and we will, and it'll be beautiful. The other thing is that we have these different lyocells, and so everything that is like polyester, especially like cheap polyester, should just be gone, anything PET based. And we can use these lyocells. The problem is that right now, a lot of them they cost more than we just cannot compete with something. We have to realize that synthetics are literally government subsidized because of the oil industry. It goes back to every natural fiber we're up against, and also alternative energy, like everything right in this space, we're up against this, not just the barrier to get the technology to what should be an equal pricing point. We have to go above that, right? So we also are looking at there's a little bit of infrastructure change around the production of lyocells. And traditionally, lyocells have used a bit more toxic chemistry, which again makes it cheaper. So there's just a couple different steps there that need some back-end infrastructure. But we do have it, and this is not an unsolvable problem. And I think once the brands, and this is where I can talk about my new company, Mothership, once we can get the feedstock costs down, the processing costs of getting them this high-quality cellulose to process with, I do believe that other things will fall into place. If there are like large mills and producers that can get the right inputs, they have the infrastructure there to do it. They can switch over. There's relatively easy ways, and this is a term in manufacturing where there's a path forward to switch over those kinds of mills.
Can we stay on this point? Because I think we had Janine Benyus on the podcast talk to you about this. Like, all this stuff makes so much sense, right?
Yeah.
I mean, we can continue talking about this, and everybody's going to buy into this who's going to listen to this. Like, I don't think there's anybody, unless they're like diehard.
Unless they're like, it's exciting. Our point is to try and educate. Until I met you, I didn't know half the stuff was going on.
Yeah, exactly.
So I want people to know, and it's so exciting.
Yeah.
But
it is.
But
and
the barriers. And is legislation the answer? Should governments, we be asking?
I would say maybe a step before that. The reality for me is always, when it makes so much sense, there's two things that could be the case. One, it doesn't make a business case yet, or it's, as you say, adverse kind of regulation because there are special interests involved. And I think we're basically talking about a situation where it seems like both are somewhat the case. So I want to maybe look at the economics a little bit more, because with electrification and with solar, when this hits a certain price point, I mean, everybody's going to switch to it. So how can we get there, and what are the challenges ahead for us to get to that inflection point?
Right. Yeah. And you hit it right on. Like, the reason that I want to be in industry and doing applied work is that I saw so many amazing things in labs that were not being commercialized. And there's a lot of reasons behind that, not just cost. There's personality types and who wants to run businesses and all those things, right? But one of the reasons that I now am working with Mothership as a CTO, and we have a technology that's a sort of centrifugation technology that separates agricultural waste into different ingredient streams. So cellulose, glucose, lipids, proteins. And the way that I ended up at this is because of the problem with making things like fruit fiber, where we could never get that fabric down to the price of a cotton, to organic cotton. And as you start investigating it, it's all about the upstream processing costs. So I used to call it the couture waste problem, where we're like literally like like hand producing, hand processing waste. We cannot have that as the paradigm if we ever want this to scale.
Right.
And so that's what Mothership is trying to do. And the other thing is that it's also this kind of, when you start to like look at different organisms and materials that are all around us, like one of the first companies I started was in algae biofuels. Talk about government infrastructure problems. But I started getting very close to looking at algae as an organism and what's inside it. This is microalgae, and it's this beautiful, perfect model organism that inside of a single cell, there's carbohydrates, lipids, proteins. Like it's like this its own little microfactory of making everything we need. And we were like piercing and pulling out the lipids to get oil, but I'm like, oh, we're throwing away cellulose and protein, like an alginate. Like, this is so this idea of like side streaming or getting multiple ingredients from one organism is really where we should be. And that's what Mothership is actually working on, because a lot of those, what we call waste valorization techniques, which we were trying out in Pangaia, and I was on some research grants on, it would be when you were trying to pull out one thing, trying to pull out the alginate, you destroy the other things with chemical processes. And so ours is actually a way to preserve all the things at once, and in the best way of like most of my favorite technologies that comes from a different industry. It's about this transfer of ideas and applying something that was built for something and into something else, and then you have a whole new life in it. And this was made as a med tech innovation that was to solve sickle cell anemia. So it's literally for the body, where you pull the blood out from a person, and it was sensitive enough, a density gradient separator, that you could pull out just the sickle cells and then return the rest of the blood. So the rest of the blood was kept clean. And so we're doing a much less high-tech version of this. I like to say that we're low-resing it.
Right. Nice.
Right, to work on agricultural waste, but we're making it more industrial and a lot in cost effective and all those things, and obviously don't need clinical trials and So in that way,
is this taking glucose from waste?
This is glucose.
Is it that process?
Yeah, exactly.
And explain to us what that's used for.
Can maybe take a step, so just to get everybody on the same page, so I understand what's going on. Yeah. No, all good. Really great to understand this. So there's a bunch of biological waste in agriculture, and that's basically abundantly available, right? And we have this as a byproduct of society, really. And you're saying that currently the way we can use this stuff to make the things that are actually sustainable, we use something called, which I love, like couture waste management, or whatever you called it. Yeah. Right? And this is obviously silly. So what we actually want is we want to have a very efficient way of taking all this bio waste and turn that into various different streams where you can get the lipids and you can get the glucose and various different things out of all that waste. If we're able to pull this off in a very efficient way, then we can get to price points that make those materials really competitive with the cottons of today.
Exactly. If you think about it this way, nature has perfect cycles of building things up and breaking them down, right? And so we as a culture need to have similar cycles. We are really good at building things up, making things. We're not very good at breaking them down. And this is what true circularity is. So we need to work inside of that natural sphere to build up and break down. And so this is using a very high-tech process to actually break things down. And yes, the point is that when we have all this agricultural waste, it comes from crops. And there's so much with crops. You grow all of this biomass. We eat one piece of the fruit, and the rest is actually a problem. Sometimes it goes back onto the ground as fertilizer, but a lot of times it's burned, or it's just, And then we also have things like sargassum blooms, this phenomenon, right, where like there's seaweed taking over like all the beaches in the Caribbean and South America. And this is going to spread. This is a climate change issue, rising sea temperatures, things are out of balance. Hey, they're out of balance. That means we have a lot of seaweed. I spent a lot of time trying to get seaweed to grow, to get algae to grow. So I was like, this is like an ironic shift in the universe. But What I do know is that that sargassum that's seen as waste and is a problem, is being burned in resorts, etc., to clean up beaches and ruining ecosystems. This is full of these nutrients, right? So we can also take places like that, like polluted streams, and process them. The other thing that's really important for the crop piece is that if you think about, you have multiple value chains. We all know that farmers are suffering. As I get more and more into agri-tech, I have no idea how farmers make any money. Like, it's a miracle that you can sustain yourself as a farmer. Food should cost so much more than it does,
Yeah.
right? And so what we can do is actually come in, and our system is that we will show up at a farm, and we're just getting up and running. So we're doing our first actual installation this summer at a bamboo farm in North Carolina. But we show up and we can process their offcuts, right? And then we give a rev share back to them.
Right.
And if we pull out, cellulose, glucose, proteins, pectin, like orange peels are full of pectin, and we're having a pectin crisis right now. It's one of the only naturally occurring preservatives. So for jams, if you want to make, there's lots of things that it goes into. It sells for like $4,000 a ton. Or these are like valuable things that are just laying on the ground. And orange peels are a particularly interesting one because the peels are so acidic that they can't just be put directly in landfill. Like, farmers or whoever, the processing people, have to pay to have it taken away. So removing that cost, and then we're giving them money back.
Yeah.
And so if farmers can be like, on my land, I grew food, but I also grew the basis of bioplastics, the basis of clothing, right? They have like 4 different ingredient streams. That's really where this high-tech naturalism comes in. We're rebalancing, right? And saying, oh, we've spent all of our society figuring out how to manufacture things. Now we have to figure out how to unmanufacture them.
Yeah. It's really interesting,
Properly.
and it's essentially a vibe shift, if I want to call it that, to say your waste is my resource.
Such a trite thing, like one man's trash and the man's treasure, but and there is no waste in nature. Like,
Yeah.
I love and hate all those phrases. They're just totally true.
Yeah, it makes sense. I'd love to still maybe tell some people about, because you've done some cool stuff at Pangaia. I love what you're doing, Mothership, but like some of those examples of those things that you did would be fun for people to know what's even possible, right?
Totally.
Do you want to tell us about a few
what
of those?
all of these raw materials go to make?
Exactly, yeah.
That we can use. Yeah.
And I think one of the things we haven't really touched on as another genre of new materials is biofabrication. So synthetic biology, which was basically, we figured out the human genome back in relatively recently, like in 2000, it was fully decoded. And this allows us to basically understand how DNA works. And we're slowly sequencing like all the organisms on Earth. So we understand the mechanisms for growth, how biology literally works, like the building blocks in the code. And so what this allows us to do is to find the gene sequence inside of an organism. So say there's a plant that grows a red flower, and some part of the coding, there is a thing that says, make something red. We can take that and put that into a microbe, so a single-celled organism, and grow that in the lab. Let's not say a lab. This is like a fermentation factory. So it's like the way that you grow beer. It literally looks like you have these big silver vats and you're making beer. This is a biological process that nobody should be scared of. And then that microbe will grow red dye. And this is something that we worked on at Pangaia with a company called Colorifics, which is in the UK. They're out of Cambridge. And this is really the next generation of how we start to have natural materials and things like natural dyes. So natural dyes are amazing. The problem with them is that if you're growing an entire, like, say you're getting it from a flower, the input, the land, the energy, the water, all of these things, there's a lot of inputs that go into just processing. One field of flowers makes like 3 kilos of dye. Like the input output ratio is really high. And that's why they're expensive and that kind of thing. And that's why synthetics have sort of taken over in that space. So what we can do is make natural dyes, because it's literally the same genes and the same materials, right? It's a naturally occurring dye in an industrial paradigm that is at an efficiency level and a cost that can go parallel to synthetic. Now, that cost is not there yet. And this is one of the things with biofabrication. So the promises are unbelievable. Like, if we think about the lower amounts of energy that they use, and if we have the infrastructure in place, this can really like challenge everything about synthetic production. One of the biggest bottlenecks is feedstocks, and that is literally glucose to feed the microbes, because nothing comes from nothing. The microbes have to eat and digest something to make this color. this is like a kind of weird secret niche problem.
That's what you're working on. Yeah.
The way I got to know was that we need, so one of the things that we can pull, we need waste sources of glucose that are not competitive to the food supply. It makes no sense to grow sugarcane, use all the resources to do that, and then feed that to a microorganism. We need it to come from waste. So we can pull glucose, or even pull cellulose and convert it to glucose through a process to feed microbes at a much lower cost, and also in a way that makes sense with carbon balancing.
Yeah.
So that's a huge thing. That could be our entire business. Like, we have companies that are like, can you get us 100,000 tons of glucose next year? And like, the demand is to a level where I start Googling, like, how much sugar is in the world? Like, like, where are these companies getting it now? What is encouraging is that there are these new processes, right, that are coming online, building blocks for food, building blocks for other things, like this notion of like, when we think about standard chemistry, there's like tiers, there's like 5 levels of things that happen to make a chemical that you've heard of, right? There's all the inputs to the inputs to the inputs. And that's where we're getting into this base level with like a kind of this bioprocessing. So biofabrication is, I'm very excited for the future of it, but we need to fix the problems around the feedstocks and the infrastructure. Because again,
exactly. So I wanted to get to that point, because like there's 2 levels to this, right? Like one, that's the inputs, and then 2 is where all these bioreactors, right? Where the precision fermentation happens. So I guess the same problem with grown meat is a similar problem to an extent, right?
It's exactly the same.
Exactly.
Actually, it's literally the same process, and it's just like you've tweaked a different gene inside of a microbe, right?
Exactly. So where are we, say, on the infrastructure side of this? And is there an unlock that's missing there, and building these precision bioreactors at scale? Is that a problem that needs to be solved?
For sure it is, but you touched on something that's actually interesting and good, is that the same kinds of infrastructure that we need to grow new biomaterials is the same thing to grow lab-grown meat. So it can be sort of industry agnostic in a way that a lot of things cannot. So not that every bioreactor can grow everything. There are like differentiations, but you do have some companies that are emerging that are starting to work on the infrastructure of like, okay, here's an entire system of bioreactors and precision fermentation. How do we have shared space in all of this? And especially for smaller companies, this is really important. Then this is the valley of death problem, right? Where you have a startup that has an incredible technology, and they have gotten a level of funding. They're kind of into maybe a Series A. They know they can produce at pilot scale. And then they have $30 million or more to make a whole facility, and that is going to take a couple of years to get up and running. And in that time, they're going to have no revenue and we all know investors are going to lose faith. And so that's that problem where a lot of things are falling out from the business case. So if you start having facilities where you're like, hey, we can get enough time in these machines without having to build them ourselves, then that is a way forward. We need what we call these transition strategies. And then when something is very successful, then they can't afford to build their own factory. And I do think it's important to point out that in every industry, there needs to be a whole lot of ideas that are tried out, and then we'll funnel into the best ones, right? It is okay that certain things are falling off, right?
Mm-hmm. Yeah, absolutely.
You need to try like when you're a scientist, you're like, oh, if like 20% of the things I do are successful or work at all, you're like, this is amazing. I'm having amazing results, right? And in industry, it's harder to kind of come to terms with that, right?
I would note, right now, what it seems like we're spending all this money and investment in fabs now, because this has become the thing. We want to build fabs that can build chips that can feed the AI growth. But that amount of money should go into this bioreactor platform technology as well, because it is really the future of manufacturing at scale and sustainable manufacture, right? I mean, and who is doing this? Like, who is actually spending money on building this stuff right now?
It is starting to happen, and I think what you're talking about is you have to get the right people on board, and you have to understand that a lot of this needs to be entirely global. And this is the thing about manufacturing. We can have America and Europe going, oh, we love this, but let's be clear, like a lot of the stuff is happening in Asia and in China. So we have to get that infrastructure change happening, and that's no single country can be in charge of it, right? There has to be a lot of agreement and just a kind of, there obviously needs to be a huge business case, right? And so both of those things happening, there is lots of things moving forward. It's like, I think it's 2 steps forward and 1 step back, and not the other way around. If you think about it, it's about displacement, So
It's
if you're
disruption.
changing
Yeah.
from one kind of production into another, something is going to fall to the wayside. And that's one of the problems with, I think, a lot of what's interesting to me about, say, for example, synthetic production of fibers is if we can start, there's a lot of overlap in the kinds of actual infrastructure and literally the machines that do things like extrusion and different kinds of spinning, wet spinning, electro spinning, et cetera, that you can put in a different bio input and still use the same infrastructure.
Right.
So and to get out a bio-based, like something that is a
So the install base of some of these things is
so
still useful.
any company that is a drop-in solution, like there's a company that I advise called Material who's developed a non-isocyanate polyurethane, which why should anybody care about that is, right? Which I know, but the point is that polyurethane is basically a glue that is in everything. So every single bioleather, like there was a point when I was like, we need to stop working on bioleathers and we need to start working on polyurethane because every single one has this as a coating or as a kind of binder, right? And this was the problem. We'd get 90% of the way there and then you throw the polyurethane in at the end and then you make it non-biodegradable, right? And so this is why this is a breakthrough thing that is a non-obvious investment for fashion, right? This is the problem where like the information, the knowledge there to be like, why do we need this? We're starting to spread it, but I was like, we need to invest in this and this and this. It's an infrastructure piece. And so what they're doing is a drop-in which can go into all different kinds of manufacturing facilities. If they can drop in their pellet into an existing polyurethane machine and it comes in the same cost, that's a no-brainer, right? And so those are the kind of solutions that I feel encouraged about. And there's varieties of that happening. We do still need more bioreactors for this infrastructure change. That's a reality. And it's slow growth.
Two things that I'm getting from what you're saying about trends. One is sharing resources rather than exclusivity and that kind of fierce competitiveness and secrecy around a new technology. It's around sharing information as much as possible, which scientists seem to be better. My scientist friends say this isn't true, but they seem to be better at than, let's say, I don't know, a fashion house.
There's no one worse than
that kind of secrecy. So that seems, and you mentioned global as well, no country can do it on its own. So that has to be around shared facilities, shared information. What if we want these smaller companies to survive? They can't build this infrastructure themselves, so they're going to have to rent or have it lent to them by. But the second thing was just to go back to Omid's point a few chapters ago, was tell us what products. I loved what got me very excited looking at all of your work is that, pollution or carbon or soot can make ink, for example, or that CO2 can become
sunglasses. That's what we did.
Yeah, the sunglasses. Was it polycarbonate lenses or something? Just tell us about some physical products because we've heard about this amazing chemical process, but for Joe blogs, we don't know what that looks like
totally, you're
in
right.
our lives. Yeah.
One quick thing I do want is just backing up to the point about sharing resources. There is an issue when you talk about scientists being open to share. There is a real issue around IP and production, and especially going into Asia. Like stereotypically, things can get taken and that kind of stuff. So that is a real concern, and innovators are kind of assessing it. And there is a lot more sort of movements to do actual factory production inside of Europe because they feel safer, and so that's not a non-issue.
Okay.
Just as a point, like I don't think it's necessarily stopping things, but it gives people pause, especially when they're in phases. So having everything be more global in the sense that you can do it in different places and do it local is a comfort. But yes, so exactly the example of different products. The carbon capture thing is such a fun play because it's this idea of thinking about like it's air actually becomes matter, and this is like this transformation of energy and the whole piece about teaching science. It's so lovely. But yeah, one of the projects we worked on 2 projects with carbon capture at Pangaia. The first was around air ink, and this was actually a friend of mine from MIT who had started working on this. Anirudh Sharma, you should look at his TED Talk if you haven't. But he literally was collecting. He's from India. And he started collecting solution like soot from literally his tailpipe. He had this crazy device on his car that he would drive around. And then it was also, you could get it from factories. And then he had developed this technology that ran off solar, which could convert this into a very beautiful black ink. And what's interesting about it is people think soot, oh, dirty, polluted, whatever, but it's actually carbon. It's real carbon. So it was actually biological in base once you remove the toxicity. So that's what he had done. And this was in the middle of COVID. And we managed to get this was a crazy thing about regulation where we were trying to get his ink from India into Portugal, where we were manufacturing. And it looked like we were importing pollution from India into Europe. And it took like a whole, like 4 scientists to figure out how to do this, where we had to write on the customs form, like some sort of breakdown. We went down to like molecular structure to like show that it wasn't actually a pollutant. And there's all sorts of crazy stories around this new biology stuff where it's not the regulation, and it, even if it's not unintentional, is so behind, like they don't understand what the new material is. So it gets classed as something else, and then there's a massive tax or just all these things. But yeah, so that was one example. And we used it to print black on all of our garments. They have a little text block that says what they're made of, where they're made, just a little, we call it our, our transparency text block. And so that was one project, and that's a kind of an obvious one where you can go, okay, black soot to black ink,
Makes sense.
But when we worked with 12, which is a really innovative company in Silicon Valley, they were actually doing air capture carbon, right? And their technology pulls CO2 from air, and they were looking at basically the exhaust from all different kinds of chemical factories. And this was a great story where they were fully intending to go into the existing chemical manufacturing infrastructure, right? So that's a good play. Like you're remediating stuff on site. Anytime you can tap into an existing giant industry, that you're set up for success. But what they were doing was they were making the basis of a lot of different kinds of chemistry from this air capture, and so for the basis of plastics. So we used their material is the basis of polycarbonate, and we made sunglass lenses out of it. But this is, again, we're back to the couture waste problem. Now they were in pilot mode, and when we were first manufacturing, each lens, I believe, cost $600 just to make. and right, which and so this kind of thing, everything was set for the cost to come down, but we didn't make that many pairs, and we always tried to explain to people, we're not doing this as a capsule collection. Every product that we're making has a path towards the price is coming down. There's an abundance of CO2. Their technology is not prohibitively expensive when it's at scale. So we wanted to kind of set that up, that there was a way forward. But yeah, so those are the two fun things. And there's a lot of carbon capture that's going into protein, because if you think about it, carbon is a molecule in everything, right? And it's not appropriate to pull from air for everything, but that is really about an infrastructure scale up. I'm not as aware of what's going on in that right now. It's not my kind of perfect area of expertise, but it's really exciting.
So when I think about the things that you said, what I like is that, one, you're saying there's a lot of waste material that needs to be classified as asset on the balance sheet rather than as waste. Which you also said, what I liked, which makes me more hopeful, is ingenious people are actually thinking about using the existing rails of the infrastructure that we've built in an industry to use that to do something that's more sustainable, actually.
Yeah.
And that means that the install base of the new type of reactors maybe is not as high as we think it is. And there's a way we can use our existing infrastructure, which is exciting. Obviously, the big topic right now is AI. Is AI having an angle here to help us overcome some of these problems? How would you think about its application to this problem?
Yeah, so one of the biggest things for AI in the space of material science is about formulation development. So there's a lot of time that can be saved, and time is money in this case of innovation and startups, right? So if you have an inkling of how we're going to tweak the formula to have better performance, there's particular custom models that are being developed where you feed it everything about chemistry, everything about biology, and everything we know about existing plastic formulation. It'll spit out not necessarily the perfect thing, but here's a cluster of how we should do molecular structure. So that could be, 5 years of work for a lab assistant, right? So it's this idea of where exactly are we going to look and how are we going to hone in on a formulation? That's one of the most exciting places around it. The other piece is there's also a big data piece. AI doesn't exist without data, so I think about them in the same breath. And one of the things that we're doing, if you think about it, so Mothership is we're going around the world and identifying waste streams, and then we're trying to figure out, we're doing local production there. Where's the closest place to sell that resource? So indirectly, we are making an entire data map of all the waste to ingredient input streams across the world. And that is another piece of very valuable data for every AI model. Like where is
Exactly.
everything in terms of resiliency? Like we do not know exactly everything about our supply chains. And so the more the AI can kind of help us manage all of that, because you can imagine you just put in like everything that they need to build something, a particular product, and every waste stream of like where that is, and then cross match. Like no single human can do that effectively. So that's a massive AI play. There's one other thing I need to bring up. This is maybe a little off piste, but when we think
Go for
about
it.
AI, there's no AI without data. There's no data without data centers, and this is a huge problem. When it's one of the biggest kind of areas of conflict around AI. Well, there's many, but in my world. So here's something that is not being talked about that has to be known about, and this is DNA data storage. So when I talk about all the promises of synthetic biology and unlocking the human genome, we now understand DNA. We know how to read it and write it, make it and synthesize it, right? So DNA is nature's natural storage mechanism. And we've now developed a technology where you can literally take digital data, so the ones and zeros of any piece of data, and convert that into the ACTG code of DNA, and then write it into
what's ACTG?
Oh, sorry. So the bonded, the pair, in the helix, the double helix of DNA, like that, right? It's these two letters that go across it. Just think of it as the code. So there's four letters that make
of DNA.
The alphabet of DNA, right? And so what I'm saying is that there's a little translation, like a literal translation. It's like the Rosetta Stone between digital and biology. So we take the digital data and put it into DNA. It's stable at room temperature, and it's like around 1/1000th the size.
Right.
So it just lives in solution. So the problems with data centers is that they take up massive amounts of energy, and they're also huge, and they have to be maintained. This is something that can just live at room temperature, and a tiny, like I think like 1 cubic centimeter could have all the data of like 100,000 phones or something.
Incredible.
Like it's an order of magnitude that. Right. And this is happening. And it's like, it is like right now, the reading and writing is slower than you would be able to access, like you're off of Google Drive or something. But first of all, it's getting faster, like day by day, and cheaper. And this is what we should be turning our attention toward. There's some sort of reckoning coming there. We need to have learned from what we did with the Industrial Revolution. Can we be aware of this now, that this is going to be the piece of AI that destroys the world? I'm not anti-AI. I'm just bringing up, like, I live in the world of physical things, and so this is where I think about this idea of how that matters. Yeah, and then of course I am a fan of robotics. The Luddite fallacy, right?
Of course,
Which is where basically every new technology is about a displacement, and it's not just, we're not going to be taking people's jobs. We are displacing jobs, and we're changing infrastructure, but we're making other jobs in other ways. Every AI and every robotic development should have a training program alongside it. That's where I think the government or companies should be. There should be some mitigation around that sort of thing.
I think you've closed one of the talks that I saw with a quote that you like. They said, most of what is knowable is not yet known. That leaves me on a very hopeful note, and I hope we can also close this with a hopeful note. And I think what you're saying is that a lot of the things that need to be known for us to get our act together are already known in many ways, right?
Yeah. And so it's not, I don't want to blame it on government or infrastructure or anything, right? It's a complex thing about culture. And that's kind of one of the things I also have loved about working in fashion and tech is you have these strangely diametrically opposed cultures, both of whom I love, right? I love being with my nerds and very practical. And then you get into fashion, and it is so glamorous and idealistic and creative, and there's a kind of an essence to it that is sort of this unknowable thing, and this thing about fantasy and the traditions of the manufacturing, and bringing them together is, I call a lot of my job like innovation diplomacy, where you're kind of talking to someone, you're convincing them this is the right thing to do. It's not a hard, sometimes it's a hard sell, but like going into an Italian shoe factory, like that, we literally manufactured in the factory that made the first stilettos, like in the 1920s, and talking to it's the descendants of that original guy about how we could put this new thing in his machine. And he did end up getting on board, over a bottle of wine, and that kind of thing. You can't go, but you can't go in there and go, my thing is right, I'm a scientist, right? This is about, there has to be a cultural communication. And that's why I think it is really important. The one thing that AI is not helping us with is connection, communication, reaching other people, or maybe there's a way it can be, but that's the part that humans need to be good at. Emotional intelligence, empathy, those are the things that people need in the jobs of the future.
Yeah, I agree.
But I think that's something that you've done incredibly well. You feel as much like a philosopher as a scientist. There's this sort of material shift from making things to growing them, or there's something sort of metabolic. The materials that you're using aren't just being used; they are themselves alive, or sort of certainly reactive in the other kind of clothing that we didn't really drill into, but the stuff that can make you bionic, which I'm really interested in. But growing and then decaying. Us going back to mimicking nature's.
I like your point, and I think you're absolutely right. There's economic reality, there's scientific reality, but then there's just human reality. And as a matter of fact, a lot of this is getting people to come along on this ride, which is really exciting. And I appreciate that you took the time to take us on this ride to get everybody who's listening to this get excited about the future.
Science is about the long term. The world will trend towards the right kind of innovation. I love talking to you guys, and thanks for having me.
Thank you so much.
Thank you for taking the time.
Thank you.